we will give a very brief how the real world case studies are using these concepts, right? As many of you might be using WhatsApp, Instagram, search, Facebook, all of them are based upon these fundamental principles. And as you grow in your career, whether you form a company or become a software developer, these concepts will be of very valuable, in my opinion, right? So these are some topics we'll cover. Now, let's start with a simple question. And I have leveraged some of this content from either that was available based on my own study. I do almost every day. At least I read a book or a white paper myself every day. That's I enjoy that reading. So this one is from a company called Byte Go. I thought this will be a good example of. So have any one of you ever thought that when you type in your URL www.google.com, what really happens? And this is the question you won't believe while I was talking. Right now I'm at Google. When I was interviewed, the same question I was asked. And I've noticed that I have myself asked in an interview the same questions to the potential candidates. And I can tell you around 80 to 90% of the time, people cannot go beyond step 1 and 2, right? So the reason I'm using this example is simple. When on your web browser, you type www.google.com, just think about it, what happens, right? So, so as an example, as soon as you type on your browser, www.google.com, the step one is goes to something called DNS. So DNS is nothing, is a think like that. It's actually the real term is domain name server. But what it does is act like a phone book for all of internet addresses that are existing, because the www.google.com computer doesn't understand. Computer is just sending to this directory service and saying, hey, what is this address means, right? Let's say, so that is what happens behind the scene. Then what happens? Then from your it looks at it, your laptop or a browser or operating system, to see, do you have you gone through this here? So that's what called the cache. So cache is nothing but a concept called temporary storage, right? And then it looks at it, hey, is it in the cache? Do I know what the address is? If the answer is no, that means it failed. Then it goes to think like that additional servers, which you will come to know as you study more about this, that basically the idea is the computers understand the IP addresses, right? It's an internet protocol address. They So to determine what is this www.google.com is, to determine that address, you have to go through all these steps from 1, 2, 3, because you have to determine what is the address is. Then behind the scene, it goes to your internet service provider. For example, some of you, um, yeah, I'm familiar with some, like you might be using Reliance Internet service or Airtel Internet service or Hathway Internet service, right? So all the service providers have behind the scene in their network layer called routers, then operating system, browser. So all of this kind of gets through. And then once the IP address is determined, the what is the address is, then what happens? Then your browser or your laptop or your mobile, it initiates something called a TCP connection, right? So it's called Transmission Control Protocol, right? Now, some of you might have already studied in your networking class. If you have not, you all of us in this industry are expected to know how does a TCP connection works, right? So in connections, what happens? To establish a connection, to know where this google.com is, so it goes through a what is called three-way handshake. By the way, this might be a question Dr. Sanjeev may ask you in your test, because this is another very common question. That's all. What is a transmission control protocol? Three-way handshake is what it is. Basically, you give a IP address, you send a connection request, then it says, yes, I got it. Then your browser acknowledges it. And then basically you say, yes, now I have established the connection. And then, so this handshake between your browser and that particular server, which is serving google.com, is successful. Then you're connected it. Then comes something called HTTP protocol. So HTTP protocol is nothing but how a uh, browser uh, browser connects to this google.com server, and then that server basically says, oh, what is this google.com is. It goes through the couple of processing of those pages, right? So basically what happens, the page is processing, like it parses your HTML document, then it does bunch of tokenization. I won't get into the detail what else happens, but behind the scene, all of this translation happens, and then your browser says, ah, this page means this. Then it displays the Google search page like what you are used to seeing, right? So the concept, why am I sharing this example? Number one, in many of the places that you will go either for interview or even understand how internet works, you all need to understand these concepts, what goes on behind the scene, right? I have put some of this 1, 2, 3, 8 steps here, more to explain what is happening. So, uh, so now you can say how complex behind the scene things are, and what happens when you type just at www.google.com, right? So the reason behind this, I wanted to introduce some of these concepts. What is cache? What is TCP/IP? What is HTTPS? How it parses the HTML page. So the expectation that we have in the industry, from whether you are going for a project manager role, technical role, you must understand these concepts, right? So, because without that, it's very difficult to process through next. Plus, if you understand these concepts, it will make you very easy to market to the industry. Okay. Keep putting, if you have any question, keep putting in the chat. We will take them later. Okay. So then comes, okay, so this is good. Then what are some of the key concepts? So this is a Rocky Bhatia and I are connected in LinkedIn, and he's a great architect that publishes very useful political presentations. And I myself have attended, talked to him as well. So I'm using one of his page, which I thought kind of describes what are the concepts that we all must know, irrespective whether you want to write code or not. These concepts are very, very important, right? So the when we say what is the use async write is, so just understand that when you write something into a computer, you say that, hey, I am going to insert this record. Other side will wait for the confirmation that your server has written it. Other side will wait for it and then move on. Why this is done? So if you think about that, if in YouTube you're uploading a video, the video is actually going through, they just upload and it just simply writes it and then moves on. You don't get a confirmation, etc. It doesn't, so server just writes it. Why do they do it? Because that is where the fast write operation happens, right? Then we'll get into some of the concepts of uh, why in the modern application, while the relational database that you might be studying in your classroom, those are important. They're also very relevant. But for these large scale massive applications, as an example, or your Instacart or Facebook, some of these databases that are called LSM queries. What is that mean? Log structured merge tree database. So basically, you write to these databases, and they just keep writing and appending rather than inserting. Like in RDBMS, you have to insert something into the a particular area, right? Then we use some concept called load balancing will come into play. This will become more clear. And these are also used because when you can just imagine there are thousands and thousands of servers that are running behind the scene. Now to manage these servers, load balancer. So this load balancer is very right. So if one of the server is down behind the scene, so why this is used? This is called the reliability concepts, right? So that is so you have to just remember and do a search on what is the load balancer does. It's a very critical concept that's used in the industry to write large scale application, right? Then comes the databases. So databases, the computer system fail, right? So the concept is called use replication. So why do you create replication? When you write in one place, you create at least one primary copy and then another parallel copy called replica. Why am I saying this is important? Because if you want an application, like for example your banks, right? They have this replication going on all the time because let's say you do a transaction and suddenly this server fails, then that's why the replication is there so that it immediately picks up, and this load balancer helps to start routing traffic to the replica as an example, right? So you have to think about these replication, right? Similarly, something called caching, right? So caching, if you remember, like I was using the example of www.google.com, and the region caching is used so that if there is a most frequent, if you're reading something again and again from database, rather than always going and reading from the database, there is a local what you call frequently read content is available, right? So region, for example, sometime if you go and uh, search something, that a page that you have retrieved in your laptop or in mobile couple of times, sometime you notice that it comes very fast, right, as compared to waiting for that what do you call that the time window circulating, right? So region, it comes very fast because it's reading from your local cache of your browser, right? It's a temporary storage. Then comes this concept called CDN. CDN, the term is called the content delivery network, right? So content delivery networks are used. So imagine that, for example, I'm sitting here in California, and some of you are in Hyderabad and in other locations, right? And this content I am sharing, actually, that's not a good example. Let's say now you have a YouTube video, or let's say you're using Netflix. Yeah, Netflix is a good example. So Netflix has created multiple copies of same movie that's deployed here in servers in United States. It also, you have local copy of that, perhaps multiple places in India. That's why when you are at home or you're for mobile, you access Netflix, the movie or even an Apple song comes very quickly. How it is coming? There's no way it's traversing 10,000 miles from India to retrieve that content. That is actually available in your local, what is called content delivery network, the local servers that are in your area, right? And where that is where this DNS, remember I said www.google.com. What is the DNS? The DNS is the directory, right? It tells that, let's say you're retrieving a movie, it just goes and checks, okay, where is this server is, and if it is local in India, it will just retrieve and immediately start playing a movie on your mobile or a laptop, right? So that is how the CDN technology is used to basically make an application that reduce the latency. Latency means your response time will be very fast on your mobile or when you're retrieving a particular content, right? Second thing is the concept that you will learn perhaps in your database class. If you're not, you must understand what is called sharding. Sharding is a concept where basically you create a partition of your database that's distributed around multiple shards or multiple, you can call it like multiple slices of data. Let's say, for example, you can say my data for January is in shard 1, February is in shard 2. Why are you doing this? The reason this is done, again, to scale so that you can use it to fundamentally retrieve the information much faster, or you can write it so that, let's say, if you have created a separation of a database, how you're storing, let's say using that concept January, February, March, and let's say the write is for only February, you don't have to go and disturb anything else, you just write into the February chart, right? Then the indexing is used, that many of you might be familiar. Why the indexing is used? Indexing is used to very quickly retrieve an information, right? Then in the world of these large application, the logging is very important. Why it is important? Because when you think there are millions of requests are coming to your application, then if you do not have what transactions are failing, what transactions are going successful, that is where as a software engineer, you have to make sure that your applications is also logging these transactions. Loggings are nothing but set of file that you log. Then various technologies are used called, you should do a search on what is the Logstash is, what is Elasticsearch is. These are the technology that enables you to write the your error logs and others into a centralized storage, and then once you write it, then you have to search it. That's where this concept called Elasticsearch comes. This is a technology, open source technology, and then keep let's say if you have to, in millions of records, you have to see what is the error happening. That's what these technologies use, and we will learn that why these technologies are used. Okay. Then comes that if you want to create always a high availability application, means an application should never go down. That is why this concept of replication is coming. So you have, if there is a failover happened, remember that load balancer I told you, that if it notices a failure, then immediately switches all the traffic to go to alternate servers, right? So these concepts, if some of my request to you will be, after a class, spend at least every day, take one topic, go and search on the your google.com and then say, hey, what is this? At least get an overview, right? So that way next time when we meet, we will get into little bit more detail. And that will help. Okay. The next now, so we have covered this high level concepts. Now the what I will do is that develop an understanding about what I call the network and protocols, right? So if nothing else from this class, or this particular, you should go and do just do AI, right? You can go to Google and turn on the AI mode, and then understand how does the network AI, the one that are making the internet work, right? Spend some time and understand how things are happening, how the networks are connecting with each other, what is the TCP/IP protocol is, how does it work, and then how the so this is a very important concept that I like to request. I think people will go into the granular detail, because if you just just do a TCP/IP, Dr. Harvinder might be teaching you all, right? It can be a topic in itself, but the engineer, you must know how does the TCP/IP works. Okay. Um, then comes how the data travels across the internet, right? You know that all this TCP/IP protocol, uh, 100 megabyte file, or let's say you loaded a document, the documents get converted into a small packets of around, I believe, 128 byte size AP connection. Remember the www.google.com is here. So then they travel from place A to place B. Now, one thing you can do is there is a good overview that you can get called the OSI layer, right? It's a 7 layer and how the data travels. Why this is important? As many of you are or a server engineer, even if you're a software application engineer, understanding how the data is traversing, it is important for you to understand that how the transaction that are happening when you have what is happening, right? That way, this kind of knowledge will help you to understand how things move across. Okay. The role of a client and a server that most likely you will learn in your client server class. So basically, it's very simple. So in my case, my laptop is a client to this GVC meet that I am using, and server, the GVC server, which is now transmitting behind the scene is actually using right. So here around 10,000 miles away from you all is getting chunked, sent across the internet in packets, getting reassembled at your location, and that's how you are able to see my voice, video, and this audio, right? So the concept of client and server is very important for us all to understand. Okay. Then comes the concept of like, so we were talking about the scalability. Why the scalability is important? So there are two concepts. You all might have heard that as if some of you are reading the news in the media, uh, that hey, this NVIDIA company is this 100 billion they are spending in OpenAI, right? Or Oracle Corporation is spending 500 billion to build another data center for artificial intelligence. So what is happening behind why this large investment is being needed? Because when you are processing, uh, let's say if it is a simple calculation you are doing, you can use your laptop and finish your job. But when you are processing a massive amount of data, a petabyte of data, how do you process it? So yes, you can have one server that you can add memory and CPU, but single machine, it always gets into a limitation, right? What happens if the single machine fails? Uh, then you cannot really scale. So what is happening nowadays? What is happening? All these companies, including small to large, they are using something called the large rack space in a data center. How? They basically get these multiple of these cheap server, they stack them and make them work together. So this way, the scaling is infinite, right? You can keep adding even if one or two server from this is an example of a rack in a data center, right? Even if one of them fail, you can just replace that piece and put it back, right? But in case of single server, that's not the case, right? So the concept of this nowadays, the people are using this horizontal scaling to scale their operation. That's why there's a large amount of investment is going in the data center space, right? But the key thing is based on the nature of the applications, you do need both vertical and horizontal scaling, right? So if you are asked, hey, uh, how will you scale an application that's getting 100 million requests a day, right? So your single server cannot be the solution. So you will have to use a combination of vertical and horizontal scaling to build your architecture, right? Hopefully these concepts are will trigger some thoughts. So then comes the I had covered the concept of called the load balancing. So load balancing is nothing but nowadays you have software load balancer as well the hardware load balancer, right? So load balancers are these are set up servers that basically distribute your traffic across several servers, right? These one, two, three, four, fives, right? So let's say you're getting 10 million requests. One single server cannot handle that, right? So you will say that, okay, do you have to do something in your program that you write to use the load balancer? The answer is no. This is a configuration you do and you deploy your software, but your software you have to break in such a way that it can be deployed across multiple servers, right? So the concept, so right now, when you walk away from this class, just say that I know what is a load balancer is basically deploy it, routes the traffic across several servers so that one server doesn't become overloaded. What happens if one server becomes overloaded? Let's say sometime you go to bank and your bank teller says, hey, the server is down or the response is very slow, right? The main reason is either they have not implemented very good the server architecture. That's why one server fails, the entire bank is shutting down, or your ATM is not working, right? So the idea there is to implement this kind of architecture. This way, single point of failure can be eliminated, right? And you one server cannot get overwhelmed. So these load balancers are used across the world by all these large scale companies that you are all must be using it. Okay. Then comes we already covered the concept of caching and data replication. Why caching is simple remain. Caching is used to reduce the latency. Why the latency is important? Because if you write an application which takes more than 5 seconds, uh, generally that application doesn't become very popular. Your end user will stop using it. So that's why you need to use a concept of called caching. So caching is used to reduce the latency for retrieving an information and improving the system response time or performance, right? So that is the term called caching. Data replication is used to create the reliability so that if one copy fails, another copy is available so that you don't lose your information, right? So think about just these concepts. What is the caching? What is the data replication and why it is used? Then comes the another concept of like, so how do you design a high performance application, right? Then another term which you all should take away is called the microservices. So this is the current architecture in the modern day applications are all based on the microservices. So microservices are, think about a an example. Let's say you're writing an application which does the ordering of a product and then doing a billing, doing invoicing, and then payment, right? So the one thing you could do is the old method of writing software was write everything monolithic. One program is doing all of this, right? Shopping cart, order placement, payment processing, and sending the order confirmation. But nowadays, that using that example, you can use a concept called microservices. You can just say my one microservices just does the shopping cart functionality, another microservice just does the order confirmation functionality, third microservice does the payment processing, fourth does the order confirmation, right? So like for example, if some of you are using Amazon.com or Blinkit or Instacart, they are using this independent microservices. So this way, you have focused development, you can test it, deploy it. So the concept of microservices is very important for you. Plus, it helps you to enhance it. Let's say you have a 10 people team, one person can work on shopping cart, another can work on ordering, so things like that. Plus it helps you to isolate the issues where the issue is happening, versus if you had that one big program, then it's very difficult for you to debug, and then you can have potentially a system wide outage, right? So walk away with understanding it, what is a microservice architecture is and why we must know. Whether you are taught in your GNU this concept or not, but the important thing is that you must understand this and know to explain to others, plus develop the software to develop in a microservice way. Okay. Then comes the database sharding, which I had covered. So why this sharding is used? This is to basically, rather than writing in one location, you distribute your workload across multiple servers. Why? That way, you can have a distributed database available across multiple shards. Shards means the partition. So let's say this is a file folder 1, this is a file folder 2, this is a file folder 3. Some of them are still empty. So the reason you distribute this helps you to scale. Let's say you have to store petabyte. Petabyte means 1000 terabyte of data, right? One option is just put everything in one. But if you distribute, it provides you performance because you can just put in shard one, shard two. Like remember the January, February, March example I used. So this way you create a high performance application, right? And the other is that the second concept is not how do you improve application performance or latency. So one is called there's concept called synchronous processing and asynchronous processing. So asynchronous processing is basically you are writing and then moving on, writing and moving on, right? Synchronous processing is also used. So what will be a good example of synchronous processing? So synchronous processing is specifically used. Let's use the bank example. When you are withdrawing a money from your ATM, that is a kind of a synchronous, or there's a term called two-phase commit is being, because you want to withdraw the money, then the machine is saying was the money successfully withdrawn and what did the end user took that money out, only then they go and debit your account. So behind the scene your application is doing it's think like as a sort of synchronous processing, so that way credit and debit match, right? But if you are just doing, let's say, uploading a file, there's no reason to keep keep checking is the file successfully read or not, right? As an example. So then you just write it and move forward, right? Content delivery network, we already covered the example I used about the movie being distributed around the globe, so that if it is closer to you, then it minimize latency, it will speed up the delivery, and hence your performance will be faster, right? How the queries, I think in your database class, you'll probably learn how the queries are optimized, right? Like SQL and NoSQL databases, there are two kind of things. So the indexing is one example, caching is another example. So those are the concepts that you will have to use to basically create an application that can perform fast and give a very good response time to your end users, right? So now let's say the other is that why the reliability and security is important. If you remember, the when you have a multi-million transactions coming to your application that you have built, you have to build what is called the logging, right? So logging is basically to review the issues that are happening, right? So what it does, it enables you to monitor what is happening plus alert if there is a potential problem is happening. The detailed logging is done. So like in your program, uh, uh, you have to, when you're debugging, if you don't put a, let's say your printf or whatever the language you're using, but in a large application you can't display everything on a screen. So that's why you log a record in a database or in a file system. Why it is used? To troubleshoot the issue effectively. Particularly when you have millions of transactions, you cannot display every issue on the screen. And that's why this is used for two purposes. One, for monitoring if your system is behaving right. Second thing is to debugging. And third is to read that and create a critical incident so that you can recover your issues and minimize the impact on your end user, right? So think like when you are thinking about the modern application, these concepts you have to keep in mind to design a system that scales to millions of users around the globe, right? Then comes the security. Now security is very important, right? You don't want people that to access the data which they are not supposed to. So that's why there's a concept called authentication. So authentication means it basically allows the user ID and password is one, but then modern day you are seeing, if any of you have your bank account, sometime you get you log in with your ID and password, but then you also get a token that you have to enter. Why it is implemented? To really validate whether it is only you and you are the one accessing it, right? Then Other concept is used, let's say, the data encryption. So particularly, this is very popular when, let's say, somebody breaks, let's say, a hacker breaks into your application. But if the data is encrypted, they can, even if they got through the user ID password, but if the data is encrypted, they cannot really make any sense out of it, right? Then third concept is called access control. Once you get into the application, then you are basically allowed what you can or cannot do. As an example, for a banking application, a manager can do multiple things, right? Can retrieve cash, can do credits, can do debits, can oversee what an end user is doing, but your tailor can only issue and receive cash, right? So that's called the various permissions are implemented. So as you are designing your application, you have to think about this, right? And the regular security assessment is needed to make sure there is no vulnerability going on, right? So these practices, like for example, some of you may choose to, hey, I want to become a security engineer or a security analyst. Then these concepts very will be important for you to understand. Okay, but even as a software engineer, you have to think about that in your application. You have to implement these controls to make sure only your end users can only do the transaction what they are allowed to do, and nothing more and nothing less. Right. Then comes the disaster recovery and continuity. Why this is used? This is, you might have heard, the data center failed, but the application they were able to switch over to another operation. So that is where this replication concept is coming up, right? So data are getting backed up in a primary location. Let's say one in United States, another copy might be existing in let's say Australia, India, and all, based on your nature of application. So this is done so that your global application is continue to operate. These are some advanced concept, but I think the idea is for you to know in case you were asked that, hey, how will you design an application that never goes down? So that is where you have to have this database, the failover and recovery procedure mechanism in place. Okay. Then let's use some example of let's say what is social media, like for example LinkedIn, Facebook, and all. They are using actually this large scale, and in one of the class we will go through this architecture of most likely how Netflix or Facebook architecture is. So those will become more clear. But the concepts are, they use the databases that are spread across multiple server and multiple location, right? So that is called concept called distributed database. Then the caching mechanism is used, which is where both the content delivery network as well as how do you reduce latency from reading. So that's why the caching is available. Caching is made available because it stores temporarily the frequently accessed data. So you don't have to go all the way to all the layer of database server to retrieve it. All these applications are using microservice architecture, right? So definitely do a search after this class, overview of microservices, how they are done, right? uh, the e-commerce, right? I told you that the e-commerce platform, they build fault tolerant so that there is no failure, whether there's a hardware failure or database failure. So this picture is kind of highlighting that, let's say you're in a data center, right? If one server fails, another takes over. This database is also spread across multiple servers so that there's no single point of failure. And then load balancer makes sure that high volume transactions are getting sent to across multiple server to meet your needs, right? So the other concept is, which we might cover, is called the cloud native. So you will hear a lot about this, hey, container technology. You will hear term called Dockers, right? How the orchestration is happening across these multiple server. What is the serverless computing is. So these are all concepts that are important, whether they are taught in your class or not. But I want you to do some research so that next time when we meet, at least when we cover the advanced topic, you will know that, hey, what is this container is, what is this Docker is, why this orchestration is important, what is the serverless computing is, right? So the reason, these are the concepts that are, let's say, for example, if you go to Amazon.com and just say, hey, provide me overview of cloud native application, you'll get a very good white paper for you to study, right? Then, in conclusion, what I wanted to, so that we can answer a few questions. Uh, in whether you are a beginning engineer or experienced engineer, understanding the fundamental is very, very important for you to do well in your career, as well as in, even if you build a company, you must understand this, right? The core design principles, which we covered: reliability, security, scalability, caching, microservice architecture, is fundamentally very important, right? And then in our next session, we'll probably cover and get into a little bit more detail. Then we'll cover an example of, let's say, Netflix or one of the application, how that has been designed, so that you get some insight into it, right? So with that, since I've been doing most of the talk, let me pause. This was the prepared content I had, but I'll be happy to take few questions, and then there will be some set of assignment that I want all of you to do before we meet next time in few weeks. So back to you, Dr. Sanjeev and team.
Thank you, sir. Uh,
Yeah,
uh, Student may ask any questions. You may
yeah,
type.
yeah.
Yeah,
Yes, type, ask,
you
whatever,
you
and
may
see if I
type
can
here,
answer.
or you may ask any question if you have any.
And also tell me, was this helpful,
Yeah.
useless, so that
Yeah.
we can adjust next time? Yeah.
It is giving a lot of insight related to the today's
Hmm.
actual scenario, what exactly happening, like in
Hmm.
Facebook, Google, how they are working, starting with the internet, how internet works, then various architectures, and how load balancing is important, how various servers are working, what is microservice, and a lot of stuff you have covered here. So hopefully our students are getting some sort of insight related to that, because just now they have started learning the core subjects related to computer
Hmm.
science and engineering. So
Hmm.
we have kept design thinking also, and they have learned Python. Now they are learning data structures, then
Hmm.
operating systems, and the operate of the OOPS concept they are learning in this semester. They are right now in
Great.
third semester. And
Okay.
so, any question from student side, please go ahead and ask if any question. You do it fast.
Hey,
Or
no question is a bad question, by the way. Okay. So,
you can type it here also. Or
yeah.
you, if you want to express anything, you can come up and explain.
So either I did such a good job that everybody understood, which I doubt it, or people are feeling shy. So
Yeah, that
let's see from your classroom. Anybody has question?
uh, classroom.
Yes, you will. You all will be getting this PowerPoint. Yes.
Yeah, you are going to get PPTs of sir session, as well as you want to get some insight related to any particular topic. You can type it here, or you may ask any other question also.
So Tarun is asking, we've been reading about how AI training is putting a huge strain on data centers, taking up tremendous amount of water, electricity. What are the new technologies or approaches you're seeing that might help solve these problems? Okay, so this is actually is an area that I, particularly on the power generation, I don't have the expertise. However, the one thing is that at least in the United States, I'm seeing the moving to solar energy, nuclear power is one of the area rather than coal burning, and that's happening quite a lot. There is a companies are also creating um, the set of new architecture which is minimizing the power consumption. So if you'll see that, if you do some research on NVIDIA or other similar companies. Like, so they're creating new kind of chips that will generate less heat, and hence less cooling is needed. So so that is the kind of things are happening, right? However, this is a research area. If you are interested in, could be a good career to build in this to solve this problem, because this is going to continuously increase the whole investment in the AI training, and then bringing new data centers that are getting built all around the globe, including, I believe, in India too. Right. Okay. All right. So I think if you which I started this session, right? The knowledge you have, we are all living in a knowledge economy. Dr. Sanjeev and your other professor can teach you, they can take you to concept, but the ultimately the responsibility is lies on all of us, right? That what level you can take your career, what you can do. I believe you all can be entrepreneur, you all can do anything you want in life, right? But the idea is to have to focus at least 1 hour a day, rather than scrolling on the infinite scroll on your Instagram. Do some infinite scroll on just choose a topic, right? We covered many topics today, right? So my request to you all will be, I'll send you maybe a 20-30 page document around, and I want all of you to actually spend some time, even if you get 10% of it, it's okay, right? So that some of those concepts, I am expecting a dialogue among us. Some I may be able to answer, some I will expect you to answer. We will, working with Dr. Sanjeev, will also give you some interesting challenge that maybe you all can form a group and do a knowledge transfer, right? And the skill and knowledge is essential, right? Number two is essential is your communication, right? How you communicate, what you communicate. And so there's no, what do you call, you cannot succeed if you are not able to communicate effectively. And then third thing will be teamwork, how you work with others. So we look for, when we recruit people, we look for a couple of things. One is the teamwork, right? Teamwork, because there's nothing today that you can do all alone. So you cannot like step there and put somebody down and very highly skilled people fail because they can't work well with others. They fail, right? Whether you are from whatever institutions you are in, right? It doesn't matter. If they can't work with others, they will not succeed. So hence, the teamwork is important. So that's why if in your classroom you are given a project work collaboratively as a team. No, don't just compete. Oh, I need to show Dr. Sanjeev that I did all the work. That's actually a failure. You should do the work to help your other colleague, right? So, and then do a practice presentation, right? Which is very important, right? So I think uh, so those are the kind of things I would say. I think there are a few questions. So Srija, very good questions. You're saying how scalability is useful in improving the performance, right? So I think we use the concept, right? So think about that. If you have a single server that's getting 100,000 requests, right? So let's say the peak connection. Remember that www.google.com example? There's no way a single server can handle that. So what will happen? You will wait. So when you will wait, then the response time will be slow. When the response time is slow, then your end user will feel, oh, this application is not responding. So the idea is, that's why we create that microservice architecture, and then create distribute it across multiple servers, right? That's how you improve the performance. Second question is from Roshita. They're asking, how do the design principle help in balancing performance and cost? Yeah, that's actually, cost is very important, right? For any applications to succeed, you need to consider the cost. That's why the microservice architecture that I said is important, right? Cost is also the cost of developing a software, cost of deploying it on a small servers, right? That's why the horizontal scaling. So all these companies are using very low cost servers that are commodity servers, and that's where they deploy it, right? So that's why that scaling is very important, right? So the balancing both is important as you design your software. As a matter of fact, in one of the class we'll talk about the cost and performance also. So I think Neelam is asking, could you bit about your career path and progression? Yeah, good question. So I actually started as a right out of college when Dr. Harvinder and I was studying together. So I started as a software engineer. Somebody's asking a question.
Good morning, sir.
Yeah, yeah.
Sir, where we are using this technology in data science or in machine learning?
Okay, good. So I'll come to that. Let me answer Neelam's question. So I started as a software engineer, means was writing code and developing. Second thing I did, I was always hungry for more work. So as I used to finish my work, I used to ask my manager, give me more. So they saw I took on the areas where I had no idea. I took on the area, did my own study, went to my managers and asked for more work. So they gave me incremental responsibilities. So very quickly, I mean, my first 3 year, I became a tech lead. So then I took a subset of a project. Then I showed the demonstrated skill of leading a team and people. So I became a technical manager. And then slowly from technical manager, I became a director in a large company like Hewlett Packard, LinkedIn, and Gilead Sciences. I chose every 2 or 3 year a new role as soon as I was getting bored. So that's how I scaled myself. But continuously, I did continuously learn. Even today, I still study every day at least 1 hour myself, right, on a new topic. So it has been a tremendous journey. I've worked in 8 to 10 different business industries. So it's a fun. This is, I think, the best career possible that you can ask for. The life is not boring. Right? So I think there was a question around the how do you use this concept in machine learning or data science? Actually, these are very, very important, right? You will run across, let's say you are given, hey, now do a create a aggregation of information of 100 million row file. How will you go about doing it? There's no way you can process a 100 million file, 100 million row file on a single laptop. Your Excel will actually fail after 1 million or 2 million, right? So that's why the concept of distributing the 100 million row file that might be of multi-gigabyte across multiple servers. That's why the concept called the distributed database comes in, right? And then you will write your R or Python programming to launch. There's a concept called behind the scene called Hadoop that is a little bit advanced, but that's nowadays that the distribution of your work is done by this cloud-based architecture servers like Amazon provided serverless architecture. So I think that what you need to do, whoever asked that question, go and say how will you process this 100 gigabyte file, right? And then you will get the answer. So these principles are still important, right? So the next question is, how do the company like Google, Amazon handles millions of user requests at the same time? I think the same concept. They have distributed around the globe, thousands of servers, and distributed the content using the content delivery network across the globe. And then you're using load balancer in every region to route the traffic based on where the end user is coming from. They use that if somebody is coming from Hyderabad, then they will direct you to the Hyderabad location. So that's how this is where the distributed load balancer and architecture will come. We'll review that with an example in next session when we meet. Right. So let me answer the last question. I think since we're running over. a real world example where AI significantly improves software performance or scalability? So I think the answer is not really. So AI is in the infancy stage. What mostly people are using right now in terms of writing, getting the answer, writing some code. But you still have to go through this design principle to design the performance and scalability. AI is not going to automatically solve it for you. Okay.
Okay, fine.
Oh,
Other questions we may take later on. And the
sure.
sir has a tight schedules. He has
Yeah.
given 1 hour time to us. And
And Vaishnavi, hold on to that question. Do your own research and then we'll discuss it next time. Okay.
yeah, yeah, thank you,
Okay.
sir, for your insight and your
Okay.
valuable, precious time you have shared with our students and faculty
Sure.
members. And we would like to thank, and we would like to give a lot of gratitude from our side. Thank you very much, sir. We hope
Thank you.
we'll have a next session soon, so that
Sure.
we'll do them. Thank you.
All right.
Thank
Yes, Anirudh. Yeah. Okay. Good question. Okay. Thank you. So I'll send this. I will send via email so that you can distribute to the team. Right?
you. Sure,
Okay.
sure.
Thank you. Thank you.
Thank you.
Atirek Sharma, WhatsApp video.
Thank you. Thank you, sir. You may discuss.